Okay, we'll go through the solutions now for those examples that I'd signed in class. So car is initially moving to the right at 10 meters per second when the brakes are applied, giving an acceleration of 5 meters per second to the left. So car is traveling, brakes are applied, and so what we're looking at here, when you apply the brakes, the acceleration is going to be in the opposite direction. So the car is going to be slowing down. What we want to find out now is excuse me, how much time passes before the car stops. Well, let's look at the information first that you're given. You're told that the velocity of the car is 10 meters per second to the right. The acceleration, though, is negative 5.0 meters per second to the right. So if we change, directions have to match. Here it was left, we have to change it to right. When we change the direction, we change the sign. So from positive to negative. If you look through your list of formulas, then I'm going to involve the acceleration, V1. You also know what V2 is, because you're told that the car stops. So V2 is 0. So the only formula we find right now that applies, V2 equals V1 plus AT. So V2 is 0, you know what V1 is, you know what acceleration is, so now you need to solve for time. So bring your V1 over to the other side. V1 is 10. Don't forget the negative is already there. Acceleration is negative 5. So negative 10 divided by negative 5, and your time is 0. If you work it out and get a negative answer, then you've done something wrong, because time should always be positive. Now the next question, determine the displacement of the car at the position where it stops. So how far did the car travel? Now you have time, you know the velocity it was moving at and the acceleration. So you know the beginning velocity, you need to find its displacement, and you know how long it was traveling, and you know the acceleration. So 10 times 2 seconds it was traveling, plus a half, here was the acceleration while it was trying to stop, and it was traveling 2 seconds. So 10 times 2 is going to give us 20, a half times negative 5 times 4. 2 squared is 4. So 20 plus a negative 10. And it's going to travel at 10 meters. Since this is a positive answer, it means our direction stays the same as we were told. So 10 meters to the right. And remember to include your direction here. And we can write that in scientific notation at 1.0 times 10 to the 1 meters to the right. Okay, an object is thrown straight upward with a velocity of 30 meters per second. How long does it take to reach its maximum height? Again, look at the information you're given. You're told it travels 30 meters per second up. You also know what the acceleration due to gravity is. Acceleration due to gravity is negative 9.8 meters per second squared. And how long does it take to reach maximum height? At maximum height, the velocity would be 0. So which formula applies here? If you look down through your list, what involves V2, acceleration, V1, and you need to find time. At your list of formulas, you're only going to have one that's going to apply, and that will be this one. And now it's a matter of filling in the information you know. So bring your V1 over to the opposite side. Positive becomes negative. Fill your numbers in. 0 subtract 30. Divide by 5. Oops, that should be a 9.8 there, folks. And I fix it here, but that should be a 9.8. That's a mistake there with the 5. So divide by negative 9.8. And negative divided by negative, 3.06 or 3.1 meters per second. And we will round it to 3.1 because when we look back through our digits here, 1 decimal place is the most accuracy that we have. Example 8. A baseball strikes a glove at an initial velocity of 35 meters per second to the left and moves the glove back 14 centimeters while coming to a rest. What is the average acceleration of the baseball while in contact with the glove? Now, I didn't include a direction in the first one when I assigned the question, guys, but I think it works easier to give a direction here rather than saying forwards and back, because the back here is the reference when the glove moves the ball, or when the ball moves the glove back. So think of this: as you're catching a softball or baseball, when the ball strikes the glove, it is going to move the glove back. If you did move your hand back or didn't push it back, the ball would probably just pop out. So let's look at the information you have. You're told it moves 35 meters per second to the left. That's the initial velocity. It will move the glove 14 centimeters in the same direction as it's trying to stop it. When the ball stops, it's going to be traveling at 0 meters per second. And we need to find the acceleration. So which formula is going to involve V1, displacement, V2, and acceleration? This formula here. And now you just simply have to fill in your information. You know the displacement, V2 and V1. So 2 times your acceleration. Displacement is 14 centimeters. V2 is 0. V1 was 35. Now, what you have to be careful of here is when you're doing the squaring. V1 is getting squared, not the negative sign on the outside. So this is still going to remain negative here. 2 times 14 is 28. To find your acceleration, divide by both sides by 28, and you get negative 43.75 meters per second squared to the left, or 4.4. Sorry folks, that should be 4.4 times 10 to the 1 meters per second to the right. So 4.4 times 10 to the 1 meters per second to the right. And when I upload the notes, I'll have that correction there. Okay, last question. A sandbag is dropped from a balloon that is 70 meters above ground and rising at 13 meters per second. The bag is higher than the bottom of the basket. Okay, so what we're looking at now is to find the maximum height above the ground reached by the sandbag. Now what you have to remember is that the balloon is still rising upward. So when you let the sandbag go, it will still move upward for a moment before it starts to fall back down. So given the velocity of the sandbag, the initial velocity of the sandbag is 13 meters per second. The acceleration is 9.8 meters per second down. Now notice here we didn't write the negative in. The negative only gets written in when you're referring to an object moving up. Acceleration is always down at 9.8. If we need to change the direction, remember you change this to a negative sign. And the velocity is 0 meters per second. And we need to find the displacement. So how far does the sandbag travel before it starts to go down? So our formula here, 2 times acceleration times displacement, V2 squared, subtract V1 squared. Fill in all the information you have here and you're given. And now, notice here, we wrote in the negative, and the reason being is that the distance or the displacement has to be given as up. So we would change this here from 9.8 down to negative 9.8 up, because your velocity and acceleration have to be the same. Okay, so 2 times 9.8, you had 0 squared, it's 13 squared, and remember the negative gets tagged along. You're not squaring the negative here. So 169 divided by 19.6, and negative divided by negative will give you a positive. So the sandbag will move up 8.6 meters before it starts to fall down. So that's going to give a total height to the sandbag. It was already at 70 meters, plus 8.6. So the sandbag, before it starts to fall, is 78.6 meters above the ground. Now the next part of the question, what's the bag's position after 5 seconds? Now this one's going to be a little trickier to figure out. You want to know, after 5 seconds, how far does the bag travel? what you need to remember is the bag is still going up before it starts to fall down. So first figure out how long does it take that sandbag to travel the 8.6 meters. Then how long does it spend falling? So the sandbag's going to go up 8.6 meters, start to fall back down, and you need to consider the time of both parts. So first let's find the displacement, let's find the time it takes for the sandbag to travel the 8.6 meters. The formula that you would find that applies, displacement is v2 times time, subtract a half at squared. It traveled 8.6 meters up. It would then stop, so its velocity is 0. Its acceleration is 9.8. Now you might have got turned off from using this equation here, but remember, v2, its ending velocity is 0, so this will cancel. So this goes away. So half times 9.8 is 4.9. Negative times negative is a positive. Solve for t. First you need to divide by 4.9. Leaves you 1.76. Take square root, 1.3 seconds. So if it's traveling for 5 seconds, it used 1.3 seconds to travel up, which means we're only going to look at 3.7 seconds while it's traveling down. So it took 1.3 to go up, and now how far does it travel in the 3.7 seconds left? So we can go back to the other formula. We don't know the ending velocity. It didn't say the sandbag hit the ground, because we would know how far it traveled. We need to find how far does it travel in this 3.7 seconds. We know the beginning velocity, because it's starting from maximum height, so its initial velocity is going to be 0. It's not moving yet. It's stopped. Before it can fall back down, it has to stop. We do know the acceleration. So beginning velocity is 0. The time is 3.7 seconds that's allowed to fall. Half times 9.8 times 3.7 squared. Now, before you think I made another mistake here, I didn't. The acceleration here is a positive 9.8 because it's traveling down. You only include a negative when we're talking about acceleration going up. So this cancels here on this side. What you have over here now, a half times 9.8 is 4.9. 3.7 squared is 13.68, or 67.1 meters down. Or you could say, well, how far is it from the ground? It went down 67.1 meters. Well, the maximum height is 78.6. It went down 67.1, so it's 11.5 meters above the ground. Okay, if you have any questions, folks, let me know. I'm going to take care of it in class.